Good morning, ladies and gentlemen. Welcome back from spring break. I know we are not in the greatest situation right now, but hopefully you were able to make the best of your time. Today we are starting a new unit. We're going through chemical equations. Okay. A chemical equation is just a way to represent a chemical reaction. Okay. So in this case, we're going to be looking at the gas from a stove. Okay, here's a normal stove burner. Okay, what is going on here? So there's a gas line. You send gas through it, and then that gas, you turn the sparker on, and it starts the stove. Okay, but what is actually happening? This is the gas. This is CH4. This is methane. Methane is a common gas used for fuel. Okay. Methane is reacting with oxygen, O2. O2 is just oxygen. And it produces, okay? So know that these equations should all have arrow here, okay? So what this is saying is CH4, which is methane, is reacting with, it's being combined with oxygen somehow, okay? To make, we're making carbon dioxide and we're making H2O, which is water, okay? So think of a chemical equation as a recipe, okay? Think of it as a recipe, okay? Chemical equations, you have formulas that are shown with the reactants being on the left side. So what is a reactant? A reactant are the things, as the name implies, that you are reacting, okay? So in the equation above, methane is a reactant. Oxygen is a reactant, okay? And they're being reacted together with the plus sign. And then the arrow tells you that now we are separating it from the products, okay? These are your products. The right side is your product. Products are what you're making. So in this equation, CO2, carbon dioxide, is a product. H2O, water, is a product, okay? And we have to learn all the symbols that go with the chemical equations. So again, this is meant to be an arrow, okay? So you'll see chemical equations with one arrow. You will also sometimes see this double arrow, okay? If you see a double arrow, that means that the equation can go back and forth. The things that you're making can be undone and taken back to product form or reactant form, I'm sorry, okay? So a quick example would be, just for reference sake, cooking, okay? So when you can fry an egg, but you can't unfry an egg, okay? It only goes one way. So if it only goes one way, you would use one arrow, okay? You can't undo cooking, okay? Once you burn something, you can't unburn it. So you would only put one arrow. It only goes one way. But making a sandwich would be reversible, okay? Let's say you put a slice of cheese on the sandwich. You could take the slice of cheese off, okay? You can go back and forth. In that case, you would use the double arrow. If you can go back and forth, you use the double arrow. So that's what it means to have reversible. So if it only goes one way, you use one arrow. If it goes both ways, you use two arrows. Okay? S means that the thing is in solid form. L means the thing is in liquid form. G means it's in gas form. AQ means it's aqueous. Aqueous means it's dissolved in water. So salt water is a perfect example. Okay, and the ocean is salt water, but you don't see the salt. It's dissolved in the water. So the salt would be considered aqueous. Okay, and then you may also see symbols on top of the arrows from time to time. So if you see heat or this triangle, it means you gotta give energy in some way, shape, or form. And you may see PT sometimes, which means it's using a catalyst, a platinum catalyst to be exact. And we'll talk about more of that in the future. So today, I just want you to learn how to write out the skeleton equation. The skeleton equation is just the chemical equation without having the exact ratios. So in the skeleton equation, it doesn't tell you how much of each you need. Okay. So in the example we did in the beginning, you see that there's a 2 in front of the oxygen. That means you need 2 oxygens for this reaction to take place. And you end up making 2 waters. The skeleton equation, you don't have to do it for that. It's just the basic recipe. Or like it's the ingredients. It's not the recipe itself, because the recipe is going to tell you how many of each you need. But it's the ingredients. What do you need to buy? Okay? So this reaction includes these things, and this is what it's going to make eventually. But what I want you to do, I want to, piece by piece, step by step. So before we get to figuring out how to know how many of each you need, let's just figure out how to make the equation set up in the first place. Okay. So what I need you to do today, this is what we're going to focusing on, is how to go from the sentence form to the equation form. Okay. This is what I need you to learn how to do today. Well, that's the plan. That is the plan. Okay. So when you're reading the sentence, metallic iron reacts with, okay? Reacts is your cue. This is your cue to know that you're combining something with something else. So the plus sign. Remember, the left side of the equation is called your reactant. What is reacting? So this is a key word. So iron reacts with oxygen. So iron and oxygen are being combined here. Iron plus oxygen. Produce. Once you see produce, that is your cue to put the arrow. So produce means set up that arrow. This is now you're making something. What are you making? So iron reacts with oxygen. Iron plus oxygen. To produce. Produce is the arrow. Iron oxide. Product. Okay? Reactant. Reactant. And then your product. Okay? Reactant. Reactant. Product. Okay, so this is the chemical equation, but this is the chemical equation in word form. Now you have to go from word form to symbolic form, and for this you just have to remember, what these things are. That's what the last 2 units were for. We talked about covalent bonds and covalent compounds. We talked about ionic compounds, and you learned how to write the formulas for all of them. So now you have to put that information to use. In the chemical equations, you're going to see the word form, and you have to be able to go to the symbolic form. So iron is just a simple element. So you just Fe, periodic table, you get that from the periodic table. Oxygen, you need to remember that oxygen is one of those things that lives in pairs. You will never see an O by itself. It's an O2. You have to remember that acronym, the Hankel-Briefs. Okay? Those things tell you which ones live in pairs. Oxygen is one of those things that lives in pairs, so you have to put O2. And it makes iron 3 oxide. And iron 3 oxide is that, Fe2O3. So that's how you go from sentence form to word equation form to symbolic equation form. And these are considered skeleton equations because they don't tell you how many of each you need exactly. Okay? So here's another example. This is the example we did in the beginning. Okay? Methane gas reacts. Q to put the plus sign. Methane reacts with oxygen to produce. Produce is your symbol, or is your cue to put the arrow. Carbon dioxide, which is CO2 and steam. Reactant, reactant, product, product. Reactant, reactant, product, product. Methane reacts with oxygen to produce carbon dioxide and steam. Okay, steam is water. Okay, steam equals water, but it also equals gas. Okay, if you see steam, steam is water vapor. Okay, so if you're in a problem, let's say this didn't say steam. Let's say this just said water. Okay, instead of steam, it just says water. And this goes for everything, okay, unless stated otherwise. This goes for everything. Okay, so if it just says water, water can be solid, which would be ice. Water can be liquid, water, or it can be gas, which we call steam. Okay. If it's in solid form, you would put S. Okay. If it's in liquid form, you put L. If it's in steam or gas form, you put gas. But if the word problem, if the sentence just says water, it doesn't tell you which one you have. So it's not always possible to note what each thing is. Okay, carbon dioxide, we know it exists as a gas most of the time. The problem doesn't explicitly say that it is, so you could also take that out as well. It says methane gas. That's how you know to put gas. Oxygen gas. If it doesn't say these things, you can't always note that. So because it said steam specifically, you know automatically it's in gas form. Okay. And the writing these things aren't 100% necessary. It's just if you want to be specific, you can be specific. But this is just telling you what form they're in when they're reacting. Okay. We'll go through some quick example questions, and then I'll go through 2 problems of the worksheet that you're going to be doing today, or the section of the worksheet you're going to be doing today. And where are we? I don't want to too lengthy. All right. I'll breeze through these. In the reaction below, the products are. Remember, the products are on what side? They're on the right side. So we have CO2. What is CO2? That is carbon dioxide. What is H2O? That is water. Our products are carbon dioxide and water. And which one is that? That is B. And the same reaction, the products are what? Are they solid, liquid, gases, or dissolved in water, which would be aqueous? This, you have to look at the symbols here. We have 2 G's. G means gas. So our products are gases. And here's just another equation, another example. This is just another example. Potassium chlorate decomposes in air to produce potassium chloride and oxygen. Only new thing here is the word decomposes. Decomposition is a reaction type, but it's just know it's another cue to draw your arrow. Okay, so decomposes in air. What it means is that it breaks down. Decompose means to break down. Okay, so decomposes in air to produce. Okay, so this whole thing, because Breno told you produce earlier is another cue to put an arrow, but decomposes came before. This whole thing means that this is being broken down already. Potassium chlorate isn't reacting with anything. It's being broken apart. Okay, so man, you have a chocolate bar, you're breaking the chocolate bar in 2. Okay, you're sharing it, you're breaking it, you're making more pieces out of one thing. Okay, and it's breaking down to make potassium chlorate and oxygen. In this case, we only have 1 reactant. We don't have 2 reactants. This is a decomposition reaction. And then you have to go from the word equation form to the symbolic equation form. This is how you would do that. There's an example below that I want to do that we can do together from scratch. Aluminum sulfate, okay, that is one of the chemicals. Reacts. Reacts is our Q plus. To produce. Produce Q to set up your arrow. So aluminum sulfate plus calcium chloride makes calcium sulfate and aluminum chloride. Okay. I'm going to skip the word form and just go straight to the symbolic form. So what is aluminum sulfate? Aluminum sulfate, if I remember the charges on them correctly, would be Al2SO43. Reacts with calcium chloride. Calcium chloride is CaCl2 to produce arrow, produces what? Calcium sulfate, which should be CaSO4, and plus aluminum chloride, which would be AlCl3. And that would be the answer to this one. Okay. The word form would just be this exact same thing, except leave these in words instead of symbols. To save time, skip that step. But you guys know how to do the naming as well as the formulas. You know how to go back and forth between them both. But that's how you go from the sentence form to the equation form. And now I want to do 2 examples with you from the sheet to help you out. Okay, so let's do there's only 5 questions. Let's do number 1 and number 2. So number 1, ammonia. They're telling here what ammonia is. NH3. So we're starting with NH3. Reacts is your Q plus. NH3 reacts with hydrogen chloride. Hydrogen chloride is HCl. To form. It's okay, to form is another word for, to make, produce. To form, making ammonium chloride. Pay attention to that. So you have ammonia and then you have ammonium. They are not the same thing. So if you remember, again in the last unit, there was a slide that had a table with the different polyatomic ions. You may have to look at that table every once in a while. You can also just look the chemicals up, okay? If you don't really remember how to go from words to symbol form, you can look the chemicals up. Perfectly fine. So ammonium chloride would be NH4 Cl. Okay, this would be ammonium chloride if I remember correctly. Okay, that's number 1. Sentence form to equation form. Hydrogen reacts with oxygen. Hydrogen reacts, symbol for plus, with oxygen to form. To form, and what are we making? We're making water. So hydrogen is one of those things that lives in pairs. So it would be not just H, it would be H2. Reacts with oxygen. Oxygen is O2. It is also one of those things that does not live alone. It lives in pairs. To form arrow water. What is water in symbol form? Remember, water is H2O. And that's number 1 and number 2. The rest of them do the same thing. Just go from the word form to the equation form symbolically. That is where I want you to end up at. Okay? If you have any questions, as always, feel free to reach out to me. You can help one another, and you can look up all the resources at your disposal. Okay? Best of luck. And